Welcome to Network Professionals. Hello everyone. Welcome back to our channel Network Professionals. I'm engineer Javiria Oftab, CISCO certified instructor. In the last lecture, we discussed Chapter 5. Security devices, IDS and IPS. IDS, Intrusion Detection System, function. Detects malicious activity on the network or system and alerts administrators. It does not take direct action to block or prevent the attack, but simply identifies suspicious behavior. Example. Scenario. A network administrator is monitoring the network using an IDS. The system detects an unusually high number of failed login attempts within a short period of time. This is identified as a potential brute force attack. Action. The IDS sends an alert to the administrator, notifying them of this suspicious activity. The admin can then manually investigate and respond, such as locking the account or blocking the IP address of the attacker. IPS, Intrusion Prevention System, function. Similar to IDS, it detects malicious activity but also takes proactive steps to block or prevent the attack in real time. It is often placed directly in the network path, so it can prevent harmful traffic from reaching its destination. Example. Scenario. A network experiences an incoming DDoS attack, distributed denial of service, where multiple compromised devices are sending overwhelming traffic to a server in an attempt to crash it. Action. The IPS detects the attack as it occurs and automatically blocks the traffic from the malicious IP addresses, preventing the server from becoming overwhelmed and maintaining service continuity. Security devices, Unified Threat Management. Unified Threat Management is an all-in-one security appliance that combines multiple security features into a single device. It is designed to simplify security management while providing robust protection against a wide range of threats. Features can vary depending on the vendor, but typically include firewall services, controls incoming and outgoing network traffic based on security rules. IDS, IPS services, detects and prevents malicious activity in the network. Protection against threats includes defenses against zero-day attacks, denial of service, distributed denial of service attacks, and spyware. Proxy and email filtering filters web traffic and emails to block malicious content. Network access control manages who can access the network and enforces security policies. VPN services provides secure remote access to the network through a virtual private network. Example. A UTM appliance might be used in an organization to provide comprehensive network security, including firewall protection, real-time intrusion prevention, email filtering, and VPN access for remote employees, all managed from a single platform. Security devices, Endpoint Management Server. An endpoint management server is a centralized system used to monitor, manage, and secure end devices like PCs, laptops, servers, tablets, printers, and other connected devices within a network. Its main role is to ensure that these devices are compliant with security policies and are protected from potential threats. Key features: monitoring and management, tracks the health, performance, and security status of all endpoint devices connected to the network. Security compliance ensures that devices are updated with the latest security patches and antivirus definitions to prevent vulnerabilities. Configuration control allows IT administrators to configure settings, enforce security policies, and install software remotely on endpoint devices. Access control manages and restricts which devices can access the network based on their security posture. Threat detection detects abnormal activities, such as unauthorized access or malware, and can take actions like quarantining affected devices or sending alerts. Example. A company uses an endpoint management server to ensure that all laptops and tablets used by employees have the latest antivirus software and operating system updates. If a laptop is found to be running outdated software or has been infected with malware, the server can automatically block its network access until the issue is resolved. Security devices, spam management. Spam management involves techniques and technologies used to prevent unwanted or malicious email from reaching users. One common method is to control the abuse of the domain name system service, which is often exploited by threat actors to support their spam campaigns. How DNS is abused for spam. DNS is used to resolve domain names into IP addresses. However, spammers often manipulate the DNS infrastructure to route malicious or unsolicited email traffic. By using DNS servers, spammers can hide their true identity and bypass traditional email filters, making it harder to block their spam emails. Anti-spam measures using DNS. To combat this, DNS servers now use TXT, text, resource records for enhanced security. These TXT records can store additional data used to verify the authenticity of email senders, helping to detect and block spam. Key anti-spam security features. SPF, Sender Policy Framework, a domain name system TXT record that defines which mail servers are allowed to send emails on behalf of a domain. If an email is received from an unauthorized server, it is flagged as spam. DKIM, Domain Keys Identified Mail, a DNS-based system that adds a digital signature to outgoing emails, allowing recipients to verify the email's source and integrity. DMARC, Domain-Based Message Authentication, Reporting, and Conformance, a DNS-based email authentication protocol that works with SPF and DKIM to ensure that emails are legitimate and conform to specified policies. Example: an organization uses domain name system TXT records to implement SPF and DKIM for their email domain. When an email arrives at a recipient's inbox, the DNS checks if the sending mail server is authorized and verifies the email's integrity. If either check fails, the email is flagged as potential spam and quarantined. Other network devices, legacy and embedded systems. Legacy systems and embedded systems are two types of network devices that, despite being older or built into other devices, are still in use. However, they often present security challenges due to limited or outdated support. Legacy systems. Definition: a legacy system refers to older devices, software, or technologies that are no longer actively supported or maintained by their manufacturers but are still in operation within a network. Examples: older routers, switches, operating systems, and applications that have been replaced by newer technologies but are still kept in use for cost-saving or operational reasons. Security risks. Lack of updates. Legacy systems may no longer receive security patches, making them vulnerable to new exploits. Compatibility issues. They may not be compatible with modern security standards or protocols, leading to potential vulnerabilities. Increased target for attackers. Attackers often target legacy systems due to their known vulnerabilities. Embedded systems. Definition: an embedded system is a specialized device that is built into another appliance or machine, designed to perform a dedicated function. These systems often use embedded microchips or processors. Examples: devices like printers, security cameras, industrial control systems, medical equipment, and smart appliances, e.g., refrigerators, washing machines. Security risks. Limited security features. Embedded systems often have limited processing power and memory, which restricts their ability to run sophisticated security software. No regular updates. These devices may not receive regular updates or patches, leaving them exposed to known vulnerabilities. Hard to monitor. Embedded systems may not be integrated with modern network monitoring tools, making them harder to detect if they're compromised. Security risks of both. Both legacy and embedded systems can be security risks because they may lack modern security features, updates, or monitoring capabilities. If compromised, they can serve as entry points for attackers to access the broader network or sensitive data. Example: a company continues to use an old printer, a legacy system, connected to their corporate network. Since the printer no longer receives firmware updates, it is vulnerable to exploitation, allowing attackers to gain access to the internal network through the unsecured device. Similarly, embedded systems and industrial control systems may be used to manipulate machinery without detection due to their outdated security measures. Other network devices. Patch panel. A patch panel is a centralized device used in network setups where network cables are organized and connected. It serves as a central point where the various network cables from different devices or sections of the network are brought together, allowing for easy management and reconfiguration. Key features. Centralized cable management. Patch panels are used to organize network cables, such as Ethernet cables, making it easier to connect, manage, and troubleshoot the network. Connection point. It acts as a connection hub for various cables running throughout the network. It allows network administrators to make connections between cables, switches, routers, and other devices. Flexible connectivity. Patch panels use patch cables, short cables, to make connections. A patch cable is inserted into the panel to connect one patch panel to another or to a nearby device, such as a network switch. Simplified network configuration. Instead of directly connecting cables to devices, patch panels make it simpler to reroute and change network connections without needing to deal with individual cables or devices directly. How it works. Cables from different network locations or rooms are connected to the back of the patch panel. Patch cables, which are short cables, are then used on the front of the patch panel to make connections between the patch panel and other devices like switches, routers, or other patch panels. These connections allow the network to be easily configured, expanded, or modified without the need to physically rewire or remove devices. Example: in a large office, several workstations are connected to a network. Instead of running cables directly from each workstation to the network switch, the cables are routed through a patch panel. This panel centralizes the connections. When a workstation needs to be moved or reconnected, the network administrator simply moves the patch cable from one port to another on the patch panel, rather than dealing with the long cables from the workstation. We'll discuss the remaining topics in the next lecture. Thanks for watching. Subscribe our channel Network Professionals for more informative videos.